smack the bandwidth some more stuff. Lawful but chaotic. It is legal though. I've never seen this in my life, Zach. Yes, awesome. Please do, Sid.
My man.
Yeah, please submit some questions. I love feeling useful and relevant today. Besides, like, just clearing like dust off of everything. Okay. All right, then we have a couple options here, and then one second. Let me make sure my chat's working on this. Yes, and this is a short. Let's activate that. Let's activate TikTok. That's so weird that your teacher writes it that way, honestly. One second, I gotta match up the flowers. Dude, props on TikTok has like the most ridiculous captchas I've ever seen. Okay, you were bored and you said this is the hardest question. Here we can put one of the chats here or something for you, just so it doesn't so it's not blank. Oh well, I thought I could. One sec, extend this down. There we go. At least something there to take up the space. Okay. 1 minus e squared is negative, so tangent theta will be imaginary. Well, tangent squared, yes, right. In order for tangent squared of theta. And then let's see, what do they have for the answers here? Fascinating. The answer choices are all like kind of wacky too. Like, yeah, like a British English thing, yeah. And then this is plus tangent to the third. I don't, like, I'm tempted to... This tangent to the third is weird for me. I always like to just put things into, like, sine and cosine, because I feel like that's my safe place. Like, 1 over cosine theta plus, what is this, going to be sine to the third theta over cosine to the third theta, 1 over sine of theta? Right? What's up, Randy? So its square root angle is 90. Oh, okay. It's interesting. The solutions that were given, I can't copy paste them for you right now, are all like forms of this. It's like they have like 2 plus e squared to like the 3/2. And then 2 plus e squared to the 1/2. And 2 minus e squared to the 3/2. And then 2 minus e squared to the 1/2. And, I mean, this is 1 minus e squared. What's up, Angie? Yeah, right? Tangent theta using... Yeah, right? I guess I could pull a cosine out of here, though, no, right? Or I could pull a 1 over cosine, right? If I pull a 1 over cosine out, let's say 1 over cosine. There you are, Sib. Yeah. I'll usually, like, I'll start streaming on Twitch first just to, like, get the announcements out of the way, and then I'll switch it over to YouTube once I have stuff that I'm actually doing that's relevant to math. Because otherwise, I think some people tend to be like, yo, what's going on here? Oh, yeah, look at this. Look at this, bro. I'm e to the 2i pi, and I approve this message. Yeah, because look at this. Because if I pull out a cosine from here, right? Now this is cosine squared of theta, right? And then the sine cubed and the sine becomes sine squared of theta. This is beautiful. I like this. Because this is secant of theta and then 1 plus tangent squared theta. But 1 plus tangent squared theta is just secant squared theta. No, so this is secant to the third theta? I think I see some cool shit here. Watch this, watch this. Okay. I'm going to take my original expression here, and I'm going to just add 1 to both sides. Right? I'm going to... Let's just take this. This is me, like, seeing puzzles Also, because I like adding 1 to both sides, because then I get like 2. So if I do +1 and then +1, okay, this now becomes 2 minus e squared, right? And then this becomes 1 plus tangent squared theta. Which, we know 1 plus tangent squared theta is equal to secant squared of theta, right? So now I have secant squared of theta is equal to 2 minus e squared. And then this right here. So when I rewrote this in terms of just sine and cosine, I pulled a 1 over cosine out, which means I pulled out a secant. And I was left with 1 plus sine squared over cosine squared, which is 1 plus tangent squared, which is secant squared. So now I have secant theta, secant squared theta, which is now secant to the third of theta. Where does all this triangle math get applied? I mean, honestly, if you want to know like the most direct application in terms of like trig substitution, like this gets pulled up a lot for doing integrals that are just nasty to work with. It is also gym for brain. Yeah, I very much agree with that, Drew Taylor. Yeah, doing these types of problems which seem like annoying and you're like, what the fuck's the like point? It does train you on specific like neural pathways for like figuring out puzzles. But given that we have AI, dude, that's my same analogy. I always say this, dude. I'm like, yes, I mean, we have forklifts, but like, why would I go to the gym if I have a forklift? It's because I want to get stronger, not the forklift, you know? I love school. Thanks, Sib. Yeah. My man. That's kind of, that's what it is, you know? Yes, AI can do this shit, but then you don't get smarter. The whole point of school is to get smarter, right? Yeah, Zach says, anytime you solve differential equations, sine and cosine show up all over the place. Agreed. Yeah, they're just used a ton. So you really want to get comfortable with manipulating things and stuff. Okay, so I'm asking for what secant of third theta is when I know that secant squared of theta is this. Okay, so to get to the third, all we do is we raise both sides to the 3/2 power. This is actually really cool. That's a cool question, actually. So now I get secant to the third of theta is equal to this. And that should be the right answer. Let's see, 2 minus e squared to the 3/2. Yes, answer choice C. I'll take it. Nice. Randy, if you're still watching, this is a stream where we help people out with math and science questions. That's what we do. Harmonic oscillators. Yes, Zach, I should be talking about that. Yeah. So Zach is right. So if you ever study physics, so physics is, especially when you get to like the quantum mechanical side of things, is all waves. And all waves are described by sines and cosines. So you really want to get comfortable. It is probably my number one regret in college, like coming from high school to college, is I was still scared of sine and cosine. So whenever I saw them in like equations and stuff, I'd have like a panic attack. I was just like, I can't do things with sines and cosines. What is this world? It's only until I started teaching it right now, like 20 years later, that I'm actually pretty comfortable with them, and I like sine and cosine. And it's just something oscillating between -1 and 1 with a certain sort of like behavior, like a shape to it. So yes, that's why all this stuff is useful. It gets used in so many things. Yeah. Yes, Nick, we'll definitely have time to go over your questions, provided I can like get Discord to open on my desktop. Sorry, it's just like it's like not running today. How easy or hard is it to become it's definitely not easy to become an aerospace engineer. Probably one of the harder engineering majors to tackle, honestly. One second, I need water. My throat is like so dry. Probably because I've also been inhaling just an absurd amount of dust cleaning up from Burning Man. Like, it's still all over my apartment. But okay, Shantrick said, it's a bit hard if you don't have passion for it. Yes. Yeah, if you like what you're doing, you learn to like embrace the suck, and even if things are hard, you're cool with it. You'll get through it. You know, Sane says, I respect sine and cosine, but I'm not sure about all their weird cousins. Yeah, wait till you get to like hyperbolic trig functions like coth and like tanth and like the Mike Tyson trig functions. Yeah. Yeah, cinch and cosh. All the trig functions that aren't sine and cosine, yeah. Did you know that cotangent is 1 over tangent, cosecant is 1 over secant, and cosine is... Wait. No, cosine is not 1 over sine. Cosecant is 1 over sine. Yeah. Yeah. That's true. Yeah. Okay. Cool. Good question. I'll get you points, Drew. Oh, wait. Discord started working again. Oh my god. One sec. We're back. I can answer more questions now. One sec. Pop this out. There we go. Oh, she's back. All right, and then we start the stage. Sorry. Office hours. Okay, and then I would like to speak on the stage. Yeah, can I speak on the stage? It's my own stage. Okay, cool. There you go. Point for you, Drew. Let's see. I got some screenshots I got submitted. HHH has a fun one. This is kind of blurry, though, HHH. I can't really read this. But I'll try to do it. Yeah, if they haven't showed up yet, they will show up later, is what I say, you know? Just because you haven't seen stuff like right away doesn't mean you won't ever see it again. Let's see. The projection and the... Dude, I always forget, like... Okay, there you go. You've written what proj UV is. Proj... well, this is very hard to read. And then the component is U cross V? That's interesting. I do see yours, Sib. Yep, you're next. I saw yours as well. Triangles with vertices. And then, Nick, I see your DMs that came in. Oh, you didn't write this? Okay. Well, here. Yeah, let's talk about, like, yo, what's up, Ham? Sam! Good to see you, Sam, bro. My degree is completed. I never have to learn it. Well, you never say never, dude. You could eventually have to like learn this stuff again. Projection. What do you have to study or learn to be an aerospace engineer? Lots of calculus. Lots of statics. Lots of definitely a lot of physics. Lots of fluids because aerospace deals with, you know, things moving through the air and through space, and believe it or not, but the air is like a fluid that you move through. So it's pretty complicated, honestly. It's not impossible though, Nick. If you wanted to do it, you could. Exactly. There you go. Odin's like, yeah, don't get too comfortable, man. And then let me get the component formula. Someone said it was like U cross V. I don't believe in that. Here we go. Projections. Yeah, comp. Dude, what? There's some weird things here, man. Oh, comp V on U is... Okay, here we go. This is it. Uh-huh. Here we go. What can you really do with a PhD? I mean, lots. People take me more seriously because I have a PhD. Otherwise, I think they probably think I'm just some like strange gold person. No. Brag about it and stare at it. Yeah, there you go. It's clout. It's a clout thing for sure. Like, do I use my actual PhD in day-to-day like life? No. But the process of getting the PhD, again, is like a super like training thing at the gym. You know, it's you learn a lot during the process of getting a PhD. You could just say you have one. People do that on LinkedIn actually all the time. They just claim they have like MBAs from Harvard. Like no one fucking double checks it. But eventually you get caught, so don't lie too much. Yeah. Sometimes it's not the end. It's not the it's rewarding, exactly. Yeah. It's not the end goal, Nick, that's really worth it. It's the process of getting it is the real treasure. I think that was in a book, The Alchemist. Anyone read it before? It's a pretty good one. Yes, PhDs are pretty brutal though. I'll tell you that. Yeah. You have to have a lot of determination to do it. Okay, cool. So the projection is u dot v divided by the magnitude of v squared, and then it's in the direction of v. So I think this is multiplied by vector v. So in reality, I think you could have just done this. I think you could have said u dot v over the magnitude of v, and then I think you say like in the v hat direction. I think this is kind of the easier. This is the way I would think about it. Yeah, The Alchemist is great. It's a great book. Yes, v hat being the unit direction of v. Right, and v hat is the same thing as v vector over like this. So that's why when you substitute this into here, you get the same thing. You get the magnitude squared underneath and then the regular vector. Okay. If you want to see like a picture of like what this is, I saw a picture of it. This is from my alma mater, University of Texas. Actually quite cool, honestly. Nicholas Flamel. Wait. That's from like Harry Potter. That's a different alchemist. I'm talking about the guy who he's searching for his treasure or something. Okay, so if this is vector v here in the light blue, we're gonna say this is vector v in the light blue, and then this is vector u in the dark blue, then the projection of u on v, which is weird. It's weird that they write it this way. So the projection of u on v, which is proj v u, is taking the amount of this vector that is in the direction of this, and here you're kind of like you're taking the shadow of what it is and you're doing this, and then because it's still a vector, you then need to multiply it by the vector v, and then also divide it by the magnitude of v squared, because you got a magnitude of v here when you multiplied it by this, and then you also got another magnitude of v when you multiplied it by this. Oh, that's a different alchemist. Yeah, no. I mean, that's a cool book. That's a different alchemist. Flamel was real? Oh, you mean like he wasn't a made-up Harry Potter character? Yeah. So, I mean, how I always describe a dot product is like, so for instance, if you say like u dot v, it's kind of measuring like how much of u is in the direction of v, but I think you would have to do this to really be the amount of u that's in the direction of v, right? Because this introduces a new magnitude of v, and so you want to divide by magnitude of v. Yeah. But okay, so just by the definition here, let's see. U is 1, 1, 1. And V is 0, 5, minus 3. Okay. So let's just write what these things are. So we need to know what u dot v is, and then eventually we're going to need to know what the magnitude of v is squared. Right, and if you divide, yes, this is the other cool thing. So u dot v is also equal to the magnitude of u times the magnitude of v times the cosine of the angle in between them. And that's the last part of the question right here that they want you to solve. Oh, okay. He was a real guy. That's cool, Jeff. I didn't know that. Okay, so let's just do what like u dot v is. So if you have 1, 1, 1, dotting with 0, 5, -3, what you do is you multiply the components, the corresponding components. So we say like the matching components with each other, and then you add them up. So the first one is going to multiply with the first one. That's 1 times 0, which is just 0. And then you're going to do the next pair. So that's 1 times 5. And that's 5. Love that. And then we're going to do 1 times -3. And that's going to be -3. Okay. And now we add all of these parts up. So all these parts add together. And that's going to get us 2. Cool. So u dot v is equal to 2. U dot v is equal to 2. If we want to figure out the magnitude of v, that's like the length of v. It's kind of similar to the Pythagorean theorem. You're going to do magnitude of v is equal to the square root, and it's this squared, so 0 squared plus 5 squared plus -3 squared. So that's going to be equal to the square root of 34. And this is the length of vector v. Vector v goes in a couple directions. Like it goes 0 in the x direction, then it moves 5 in the y, and then it moves -3 in the z. And so the overall direction, which is kind of like the resultant length, you just square all the different numbers, the components within the vector, and then you add them up, and then you square root it. There's a name for this also. Is this called like some sort of averaging? There's a name for this. RMS? Is it RMS? Root mean square, maybe? Maybe that's RMS. It is the distance formula. That is true. Norm. Okay, I've heard norm before. Yeah, that's true too. Euclidean norm. Okay, well, that sounds even fancier. I'm a fan of that one. Sid wants to go to med school. Oh, that's cool, Sid. Med school is pretty tough. A lot of memorizing, unfortunately. Unit length of a vector. You're right, H. That's another true thing. Yeah. The reason we say unit length, right, is because we don't know what the units are. But it's like, it's a length in terms of units. Okay. So, now that we have u dot v, now that we have v magnitude, okay, we know that the component of u in the direction of v is just u dot v over magnitude of v. So I can say comp vu is equal to 2 over the square root of 34, which is kind of a weird thing to look at. We don't really like radicals on the bottom, so we're multiplying the top and bottom both by square root of 34. And that's going to turn into 2 square root of 34 over 34, which now you can simplify this, and you just get the square root of 34 over 17. Cool. If you wanted the projection of u on v, which is written as proj vu, that's going to be equal to 2 over this magnitude squared, which is now 34, but then it's in the direction of v. So you have to put the full vector there, which is 0, 5, -3. So, all right. You can distribute this into all the components. So this is just going to be 0, 10 over 34, which is 5 over 17. And then -3 over 17. There you go. Cool. So that's the projection of u on v. And then if they want the angle in between the two, cool. The way to get that is from here. So u dot v, you already know what that is. That's 2. We know the magnitude of u. Well, we can figure that out. U is 1, 1, 1. So the magnitude of u is equal to the square root of 1 squared plus 1 squared plus 1 squared, which is just equal to the square root of 3. Who's hitting Dr. G off VRO? What the fuck is VRO, Odin? What? Excuse me? Square root of 3. This is the square root of 34. And then it's cosine theta. Okay, awesome. So, the last thing here is to divide this out. So we get 2 over, what's that? The square root of 102? I think. Is equal to cosine of theta. Donde está mi calculadora? Very important, bro. Wait, where's the R? Shouldn't it be VIO? Am I missing something here, dog? Is there some slang I don't know? Okay, here, let's pull the calculator out. I gotta bind this to this one. There we go. Okay. So we had, what was it? We had, let me move it over. 2 over the square root of 102. So we're gonna say 2 divided by. You're just making shit up. It's okay, dude. Creativity is lost these days. And then let me make sure I'm in degree mode, and then we're gonna arc cosine that. Nice. Okay. Which gets us 78.6 degrees. Cool. 78.6 degrees it is. My fault, Unc, for using new slang. You're creating new slang, dude. It's cool. I want to be plugged in, dude. I want to be plugged into the web 4.0, you know? Okay, 78.6 degrees. There you go. Nice. Okay, good job, Ed Root. Where's his name again? Funny Snake? Funny Snake? Cool. Alright. Let's see. Sib, I think you got a good one. We did Taylor Drew's. Good. Is it possible to get better at Olympiad style questions? It is, Dylan. So, those questions are intentionally tricky, and like they're intentionally misleading because they're competition questions, right? They're not gonna be nice to you. The way to get better at those types of questions, I know people want like some magic hack or something, but it's really just to do practice ones. You have to do a lot of them. Because what you'll start to notice is that there are patterns in the tricks that are used to solve these types of things. Such as you'll start noticing, oh, you know, every time I need to add up like every other number, it's like this type of average. Or, you know, I can use this little shortcut for this. Oh, you need part B for that one? Oh, what was part B? Oh, find the vectors? Okay, all right, yeah. All right, I'll do it in a second. Let me go through the chat real quick. Yeah, exactly. Math Olympiads, Taylor, have a bunch of tricks. So the best way for you to get good at those types of questions is go find like previous Math Olympiads and specifically look at like what the hardest questions were that were asked on it. Usually like the first couple ones are just easy, they're cake. But it's like the last 5 are just nightmare mode hard. And so if you want to really just like kind of practice the hardest ones, because that's kind of like what determines whether your whatever your team does well or whatnot. And coming by like streams like this and asking other people to explain like how did they do it can really help you to gain some insight on what the different techniques are that you should know to solve these types of things. Yeah, you're welcome, Dylan. Okay, so oh, you mean question 2, not part B, right? Was this is the one you need? It's okay. We got a good I got a good little like softball intro into matrices. Not sorry, matrices, vectors. This is the first like serious math I've done since coming back. Okay. All right. Let's see what you got. And then Sib, I'll do yours. Thank you for waiting. And then yeah, if anyone else has questions, you know, if you're here seeing us on TikTok or Discord or Twitch or YouTube, there's a website down there. actualdiscord.com/submit. Feel free to just like dump a screenshot. That's what students do. They send me screenshots and I'll go through them live here on the stream. Do I know how to rasterize a polygon? I know how to use software to do it. Okay. U is that, A is that. Find the vectors x, y such that u equals x plus y. U equals x plus y. Okay. X is parallel to A, and y is perpendicular to A. So here's some unique properties about things being parallel and perpendicular. Okay. If vector x is parallel to vector A, then that tells me that the cross x cross, I hate that we're using x's and a. Okay, whatever. X cross A has to be equal to 0. Also, it tells me, right? So that tells me that like x dot A should equal the magnitude of x, magnitude of A, times the cosine of the angle in between them. But the cosine of the angle in between them is 0. And the cosine of 0 is just 1. So this is another cool property about things being parallel, is that the dot product of the two things is equal to the magnitudes multiplied by each other. So another way to write this, right, is that like, sorry, I should be doing this for my vectors. X dot A over the magnitude of x over the magnitude of A is equal to 1. Pretty cool. Okay. And then we have y is perpendicular to A. Okay. So if y is perpendicular to A, then that tells me that y dot A is 0. Because there's no amount of y that is parallel to A. That's what dot products do. They see like how much of one vector is parallel to another vector. Give it a dreadlocks and a colorful hat. You're making me crazy with the polygons, man. Okay, cool. So, and then they tell me u is equal to x plus y, and they give me u and they give me a. Fascinating. Okay. And okay, so x is parallel to A. This is really fascinating, actually. Okay. All right, let me write this out. 2, 5, negative 3 is equal to, I'm going to say, forming a perpendicular basis. See, those words scare me. They still scare me, dude. When I hear the word like basis, I'm like, no. No. I don't want to talk about bases. What's up, Monkey Man? My rec is my op from 2021, and he just caught me dude, what's your rec, dude? What, you need to explain the language here, Odin dog. Okay, U cross V gets you a vector perpendicular to both. Sure. Oh, because U is composed of X and Y? Is that what you're saying? Like, the basis of U is X and Y? Is that kind of what we're saying? Yeah. Okay, so I know this is true, right? So they give me what U is, and then they say U is equal to X plus Y. So I don't know the components of X and Y yet, so but this is true. So this is actually kind of cool. I'm going to try to do this in simple algebra terms. If we need to start invoking some tricky vector stuff with bases, I'll do it. But what I can see right away, right? Because when you add vectors together, you just add the components to each other. This tells me that like x1 plus y1 is equal to 2. X2 plus y2. Oh, thanks for the follow, dude. Okay, boomer 18. I'm not a boomer. Boomer's the reason I don't have housing, but or I can't afford a house, I guess. Is that what it is? That or all the Starbucks I eat, drink. Don't worry about it. Okay. All right. We'll see. We'll see if we need to do it. This I know for sure is true, right? Because this and this have to equal this, right? And then the components, yeah. Okay. But then I know some cool things. I know what A is. So A is equal to 3, negative 1, 2. And I know that Y dot A has to be 0. So this is really cool. So let's consider this fact of life, that Y dot A is equal to 0. Okay. If Y dot A is equal to 0, that means Y1 A1 plus Y2 A2 plus Y3 A3 needs to also equal to 0. Okay, because that's how a dot product works, is we take each individual component of our vector, so Y1, and we multiply it with the corresponding or the matching component in the other vector, which in this case, A1 is just 3. So yeah, let's remember that A is equal to 3 minus 1, 2. Okay, so this gives me kind of like an equation here, where I have like 3y1 minus y2 plus 2y3 is equal to 0, right? Wow. Oh, another follow. Thank you, Dysone official. Dysone official. Do you happen to work for Dyson? I need a new vacuum, honestly. I think I broke my current Dyson just vacuuming all the dust from my stuff. Trying to get all the Burning Man dust off of my equipment, I think, has broken my poor Dyson that I've owned for like 7 years. It doesn't want to suck anymore. I can't do radicals. Oh, I'm sorry, RK. That can suck totally. I have some videos on radicals. What do you need to know about radicals? Like multiplying radicals together, or like simplifying radicals? I have some good ones on simplifying radicals. I really do. Or like weird exponent, like fractional exponents. That's another one. A lot of radicals at Burning Man. So true. Oh, with like fractions and stuff. Okay, cool. Well, RK, if you wanna, the best way I can like help you out, if you can like find a screenshot of like a question that gives you trouble, and then submit it to our little website here. I'll do it live here on the stream. Yeah, it's right here. Like, you literally just put in you could put in your name. You'd be like, hi, my name's RK, and just upload a screenshot of it, so I can get like a better idea of like what exactly you need help with. Because yeah, saying I need help with radicals, there's a lot of things to radicals. But if I can see an example of something, then I know instantly like where you're at. The website's right down there. actualdiscord.com/submit. Yeah. It's like And then it says like submit. Yeah. Let me know if you have trouble with it, but. And I'll look for it coming in. Okay. So we know this from y dot a is equal to 0. Cool. That gives me like some help, I guess. We're having like a lot of systems of equations here, right? There probably is an easier way to do this. Okay, the other thing I know is that x dot a over the magnitude of x, magnitude a is equal to 1. Okay, so let's see if this tells us anything interesting. Well, let me use a different color for this. So, x dot a, that's going to be x1, a1. Wow, dude, Mondo with the sub. We're getting all the subs today. I got 3 subs today. Thank you, Mondo. I appreciate that. Hey, yo, teach me some stuff, daddy-o. I'm trying here. All right, so that's x dot a. And the magnitude of x over magnitude of a. Okay, so this is where things get a little tricky. Because this would be the square root of x1 squared plus x2 squared plus x3 squared. And then the magnitude of a. But we should be able to figure out the magnitude of a, right? That's 1 squared plus 2 squared. So that's 1 plus 4, which is 5. 5 plus 9 is 14. This is suddenly not nice. And this has to equal to 1. And then a is 3, negative 1, 2. Ooh, nice. Okay, I see what you submitted. Something with parabolas. This is reflected parabolas. Lots of lag on Twitch. Oh, I hope it fixes itself. Yeah, I see this one. Okay, I see it. Thanks for submitting. Okay, so then this is 3x1 minus x2 plus 2x3 all over, like, this is gross. So gross. X1 squared plus x2 squared plus x3 squared. This should all equal the square root of 14, I guess, technically. Monkey Man says, unfortunately, I didn't get that college I wanted. My points for my final exams were just a little under what I needed. Thankfully, I had a professor in another college reach out to me and offer me a place as long as I help out. Nice. Yes. Yeah, don't rely on, like, scores alone to get you into schools. It's very important to, like, try to make human connections with people that are there. And, like, yeah, this is a good thing if you're making, like, an exchange that you're going to help out as an RA. Definitely. You're showing, like, value to them, so they're more likely to accept you. What's up, Roman? You're overheating Dr. Gold's PC? My PC is fine. Although it is 84.2 degrees in my studio right now. Fuck yeah. Full ride financially. Congrats, Monkey Man. Congrats, dude. That's dope.
That's dope.
That's really dope. Good job. Okay. So let's compile, like, the things we have determined today. I think we might have to go Jeff's route because I'm not seeing anything super obvious here that's gonna work. You clicked upload, it wouldn't upload. Really? Did you submit a screenshot? RK? Really? Let me make sure. It does work because I've gotten a couple screenshots already from people today. Let me see. Yeah. Click it. It should work. Let me just test. Let me test for you real quick. If I just upload a question, this was Sibley's question. I hit upload. Yeah, you should get this page here. It should say that. Oh, RK, I just saw yours. Oh wait, that's not yours. Sorry, that's Sibley's other question. Yeah. Yeah. Try it again. Yeah, got it. Okay. All right. I'm at a loss for words. Because I have 6 unknowns. X1, X2, X3, right? I have 6 unknowns. Some guy at my college tutoring center said to use the projection formula for the X component and subtract U minus X for Y. For the X, the X component, you mean for the X vector? Or X component of what? Oh, okay, wait. I think I kind of see what's happening here. One sec. Yeah, this is me trying to like brute force some algebra, and it's not really working out. So I think I see something else here that could be kind of cool. Okay, let's visualize this. Okay, U. Let's say U is this blue vector here. I'm gonna say use the blue vector. Okay. And here, let me make this a little bit smaller. Actually, here, I'm going to put this on a totally new page. Okay. This is our vector U, right? Which is composed of 2 other vectors. It's composed of vector A, which let's say points this way. Okay, vector X. And then let's say it also has a vector. And I don't want to make them all like perpendicular to each other, right? Let's do this. Let's say this is vector Y. Because they tell me U. Yeah, right. Okay, cool. Okay. X is parallel to A. And Y is perpendicular to A. Okay. So there's some vector A. Oh, this is actually very interesting. Sorry. X is parallel to A. Okay, so let's say this thing is vector A, for instance. Just say that this is vector A. If this is parallel to A, and then Y is perpendicular to A, that tells me X is perpendicular to Y. So actually, yeah, it does have to work this way. It's actually kind of cool. Exactly, yeah. Right, okay. Right? These have to be 90 to each other now. This is sometimes why, like, yeah, just visualizing things can help you out a lot. Sir, you better do RK's question before I crash out. I haven't seen RK submit his question yet, though. I saw this one. Sorry. This one. Whoever this is. This one's, like, not too hard. RK says I'm trying. RK, do you have Discord? You can join our Discord using that link as well. And then there's a channel called Help Screenshots that you can post things to. Estrogen or test max, Dr. G? God damn. I'm all natty, bro. Dude, just eat chicken, dog. You're fine. Okay. Yes, okay. So use projection on X. Sorry. Yeah, use projection onto A to get X. Exactly. This is very cool, actually. Yeah. Yes. Okay, so look. So the projection of U onto A, right? That tells you the amount of U that is in the direction of A and as a vector A, but that's also vector X, because vector X is the component of U that is in the same direction as A. Holy shit, I see it now, twin. Yeah, that's actually really cool. Yeah, that's fucking dope. So you say projection AU is now equal to X vector, right? That's pretty cool. Yeah, I had to draw the picture to see it. Thanks, Jeff, also for like... Yeah. That's really cool. Okay, so then that's U dot A. So let's just figure these things out. So planning schedule's great. Yeah. So U dot A, that means we just multiply these two things together. So that's 6 minus 5 minus 6, right? 6 minus 5 minus 6. This goes away. So that's just equal to -5. And then let me remember what we need for projection. We've worked so much on this, dude. Sorry, I'm pulling this over just because I want it. And then I need the magnitude of A, which was square root of 13. No. Yes. Yeah, right. Very cool. Yeah, if you also like, please join our Discord. Our Discord's a great place to like get help like off stream as well. Like if we're not streaming stuff. Oh wait, did RK manage to figure it out? Oh, goat. There we go. The goat. I think I see your questions. The goat. Are these yours? Yeah, I think the goat. Right? Is that you? Is this a 5, 12, 13? It might be, dude. Okay. Okay, so U dot A, so that's -5 over 13, and then in the direction of A, so that's 3, -1, comma 2, right? So this is this vector... Is this vector X then? It's kind of ugly. I don't really like it. No, that's not the unit vector X. Right? Projection of A on U is equal to X. Yeah. Yeah, this is it. Sorry, how do I get oh, okay. And then, okay. If I know what vector X is, very cool here. So if you do, so U is equal to X plus Y. So then Y is equal to U minus X. Do you see how you just like move this over on the other side? So now you do, okay, so 2, 5, minus 3 subtracted from this, which is plus 5 over 13, 3 minus 1, comma 2. Now that equals Y. Yeah, nice. Hey, what's up, Femvox? Okay, cool. That's it. That's the answer. I spent a lot of time with this question already. I hope that makes more sense to you, Odin Root. Oh, it was a square root of 14. You're right. Yeah, I fucked that up. Sorry. A's the square root of 14. Wait, you get the process here, right? It's not pretty though. I don't think it's pretty. I don't think it's a very pretty answer. Yeah, it's not pretty.
You done messed up, Aaron.
Okay. We spent a lot of time on that question. Let me help out RK real quick, and then Sib, I'll help you out. Just because RK I know has been like trying a lot, and he's new, and he's never gotten help here before. I leave that as an exercise to the reader. Okay. RK, also, you can watch us on Discord if you want. It's probably faster. Thank you. I do need some water. I'm thirsty. You're a big Mike man. You say what you want. Yes. Okay. Okay. RK, you need help with how to multiply conjugates. Okay, this is not too bad. Difference of squares, exactly, yeah. So, here's kind of the trick here. Anytime you have, like, a plus b being multiplied by a minus b, this is the same thing as a squared minus b squared. What's Maria saying? I'm gonna need your help. I have a physics test tomorrow and I know what I'm doing. We're on acceleration. Uh-oh. I have lots of videos on acceleration and position and velocity stuff if you want to check on my main page. But also, yeah, you can also submit screenshots. How, same way RK did it here. So, in this case, this is A, right? And then this is B. Do you want to do your... I can't... No. Me doing your test for you doesn't help you. It doesn't do anything for you. This is the square root of 6 squared. Which the squaring of a square root, just they get rid of each other. So this just becomes 6. And then b squared is the square root of 3 squared. So that's just equal to 3. So then a squared minus b squared is the same thing as 6 minus 3. And so this answer is 3. Do you see that, RK? The goat. Okay, it says, oh. Okay, the other two you sent were bad. Okay, let's see it. Yeah, I know what you're talking about. I think you're talking about this one. I'll do this. What's up, Psyduck? You sent me like a nightmare hard question to go through. Average speed? Yeah, average speed is just it's different than average velocity. It's distance divided by time. Total distance divided by time. If you have an example of a word problem, Maria, and you submit it to me, I can help you like go through it. So this is what RK did. RK submitted this screenshot. There's a website right here. If you go to that website, you can upload a screenshot and I can help you out with it. Oh, no, I lost it. No! There we go. Okay, now it's back. Okay. So, the... Nice. Isn't average speed the average of the magnitude of velocity? I'd have to think about that. It's just distance and displacement are different. That's the difference. Okay, these are called technically called surds, I think. But what you want to do is you want to try to reduce these big radicals into things that are smaller. Okay. Jesus, we nasty. What did you just send me, dog? Thanks for the follow, though. So we have to get good at doing this. So, for instance, the square root of 8. Actually, let's work with the biggest one first. Let me work with the biggest one. The radical stuff definitely can get tricky. I'm going to break up the square root of 108 into smaller radicals. So what I'm going to do is I'm going to think about things that multiply to 108, which I know, right, is like 2 and 54. And then we got 2, and then we got 27. And then from 27, this is the same thing as 3 times 9, which is the same thing as like 3 times 3. Yeah, did you know how to do this, RK? How to like turn this thing into the, because then here's what you do. You pick out the pairs. So I got a pair of 2s. That's going to come out as a single 2. And then I have another pair of 3s. That's going to come out as a 3. And then whatever's left is going to go back inside the house. Okay, so what you end up getting is 2 times 3 square root of 3. So this becomes 6 root 3. That's what this whole square root of 108 is. A full house. A full happy house. Yes, isn't so nice? Gotta go back inside the house. I will do the reflection one, Boomer. I just wanted to help out RK real quick because he's been trying a lot on TikTok, and my TikTok guests tend to leave pretty quickly if they don't get help quickly. Just by the nature of it being TikTok. Okay. So this is this, okay? But then it's also multiplied by 5. Okay? So now we have to do 5 times this, okay? So this whole part here, I know this is a lot of work for just one little part. I get it, bro. But this whole thing here is going to become 30 root 3. Okay? So just trust me with that. We've gotten that far at least, yeah? Well, if you can never remember, now's the time to relearn, right? Okay. Let's do... I'm running out of colors. Let's do the square root. Let me just do all the square root things real quick. Okay. Yes, and you multiply by the outside number at the end. Yeah. So see, this square root of 108 was the 6 root 3, but then I needed to multiply by the 5 that was on the outside as well. So that's why it became 30 root 3. Square root of 48 is the same thing as 4 and 12, 4 and 3. So this is going to be 4 root 3. Okay. So when you put it into here, okay. Joseph says, "Hey man, I love your content. It's been helping me in AP Calc. It's my last year of school and I want to make it count. Do you have any tips for AP Calc?" Thanks, dude. Tips for AP Calc? Just stay ahead of shit. Like, Calc moves quickly, and also don't ever just hand wave or anything. In pre-calc, you can kind of be like, yeah, fuck it, I don't really care about signs, and like I'll deal with it later. But, or like, you know, I don't really care about the parabolic stuff or whatever. But in calculus, everything you learn, you use in the next thing, so you really need to make sure you understand it. Yes, you could do that 2, 2, 2, 3, but this is a quicker way to do it. If you recognize that you're gonna get a pair, it saves you from doing this, which like sucks. So that's 4 root 3. We're just gambling in chat. Okay, thanks guys. If this is 4 root 3, okay, you don't need to break the 4s down because it's a pair of 4s. Anytime you get a pair, you can yank that pair out. Okay? So you don't need to break them down again. You could break them down, and that would be 2, 2, 2, 2, but then you're pulling out like 2 2s, which is the same thing as pulling out a single 4. So if this is 4 root 3, then you have 5 over 4 times 4. Do you see how like this 4 and this 4 will cancel? So, this whole little part here is going to become 5 root 3. That's what this is. This is a real pain in the ass, dude, your teacher doing this to you, because they're all like different weird ones. I'm like running out of colors. Oh, confused how you add the fractions? No, that's okay. Okay, one second. Let's focus in strictly on this part, okay? So you're not adding fractions. It's 5 over 4. Well, eventually you're adding and subtracting, but we want to get every term simplified first. So this is 5 over 4, and then the square root of 48 was 4 root 3. So then this was times 4 root 3. Okay? 4 root 3 is the same thing as 4 root 3 over 1. And so now you're multiplying 2 fractions together. And if you want, we could just multiply it out. Fine. This is 5 times 4, so this is 20 root 3. 4 times 1 is 4 over 4. Now you can simplify this into just 5 root 3. So, that's what that is. Does that make sense, RK? So this whole thing is now 5 root 3. Don't want to dox myself. Oh no. Cool. Okay, it's the same thing for this one. For the square root of 50. So here's another trick with square root of 50. Watch this. I'm just going to say this is 2 and 25. And then 5 and 5. Pair of 5s come out. 2 stays inside. So this is the same thing as 5 root 2. And then look, this is the same thing that's happening, right? So I have 1/2 times 5 root 2. Oh, damn. It would have been nice, actually, if they canceled. Okay. So this is going to be 5/2, or 5 root 2 over 2. Did I get your request, Maria? Not yet. I didn't see it. I didn't see the screenshot yet. Did it say that it submitted it? It should say submitting to Discord, and it should say successful. Okay. And then it's giving you an error. Interesting. I don't know why it's giving you guys errors. It doesn't give errors to anybody else. But TikTok specifically. What country are you guys in? That might help me out. What country are you guys in? Maybe it's a different country. Why is the denominator not 1? Okay. So, yes, this is the same thing as... Oh, USA. Oh, it should be working then. Yeah. Canada. Okay. Can you tell me what the error is that it says? Yeah, make sure... Oh, yeah. Make sure you're uploading an image. It needs to be an image, like a screenshot, like a JPEG, or like a PNG. Yeah, don't upload like a PDF or something. It needs to be like a picture. So, okay. There you go. Error. Only PNG and JPEG files allowed. Correct. What are you trying to upload? See, that's the question. Yeah, take a picture. Like, use your phone if you have to. Which maybe it doesn't work with... Is this garbage because Apple uses HEIC now for images? Ugh, I hate how they make things, like, complicated. But anyways, this cancels, and so that's why you get 5 root 2 over 2. Do you see there? RK? Okay. We're almost done with things. Let's do this one. So, root 18. Or here, let me do it somewhere else. Screenshots on phone don't work. Interesting. Okay, I'll have to change that then to allow... Because what format are the screenshots on your phone? I'll fix that. 3, 6... so this is 3 root 2. The site is blocked. Aw. Yeah. Here, Maria, do you want to join our Discord? Do you have Discord, Maria? There should be links there to also join Discord. I'll go in and fix that so that it allows other images as well. Okay. So then this square root of 18 is 3 root 2. So then this is 2 times 3 root 2. So this is going to equal to 6 root 2. Okay. And then the last one is here. Square root of 8 is the same thing as 2 root 2. I'm just going to say that right off the bat. So then this becomes 3 over 4 times 2 root 2. So that's going to be 6 over 4. Or 6 root 2 over 4. 6 over 4 is the same thing as 3 over 2. So this whole thing becomes 3 root 2 over 2. Thank you. Okay. Okay, do we got them all? Yeah. 6 over 4 is the same as 3 over 2. Correct. Okay. Now let's put it all together. I agree. Dude, this is a mess. This like sucks, dude.
Obviously, don't go and do that.
Now you do whatever you.
This is a terrible question your teacher gave you, because it's so much work. Okay, so this thing was 3 root 2 over 2. So you have 3 root 2 over 2 minus 30 root 3.
Oh, someone got baby voice going on. Okay, baby voice is here. Minus 30 root 3. Well, let me make sure these are minuses or pluses. Yeah. That one's a minus. Okay, fine. The fuck is this one? That one's also a minus. Minus 5 root 3. And then plus 5 root 2 over 2.
And then that looks like plus 2 root 18, so plus 6 root 2. Talk like that the whole time. Yeah. It only lasts for 30 seconds. Okay, cool. So there we go. So, okay, this is the final thing. And then we have to combine like terms, okay? So what I'm going to do is I notice that some things have a root 3 in front of them, okay? This is negative 30 root 3s, so minus 30 root 3s minus 5 root 3s. So negative 30 minus 5, this is the same thing as negative 35 root 3s, okay? It's like how many root 3s you have. And then we have to combine these ones, because we have all these with root 2. Okay. And so I have 3 halves of a root 2, plus 5 halves of a root 2, plus 6 root 2s. Okay. 3 halves plus 5 halves is 8 halves. But 8 halves is the same thing as 4. So you have 4 root 2s plus the 6 root 2s here. That's going to give you 10 root 2s. You add the outside numbers, correct. So then your final answer is 10 root 2 minus 35 root 3. And that... See if you can click that link, discord.actual.education. It should also, oh yeah, if you go to the website on your phone, like this website right here, and you say join our Discord, this will take you to our Discord right away. Right here. Okay, awesome. Yeah, great. Yeah, try practicing those. It's a little bit of a lengthy thing, but yeah. You just have to, like, you got to simplify the radicals into, like, the lowest number radical things, and then you got to combine the like terms. Can we do the reflection question? Okay, yeah. Okay. I'll do it real quick, because that one didn't look too bad, and then I'll do Sibs. And then, Psyduck, you got one as well, I saw. Okay, let's see. Okay, the parabola with the equation y equals x squared is reflected in the line with the equation y equals x plus 2. Which of the following is an equation of the reflected parabola? Oh, I don't know. How do you do this? Let me draw it. Maybe that'll help me. Is this some matrix operations we gotta do? Yeah, right. Okay. So this is y equals x squared. And then we're reflecting it about y equals x plus 2. So that's like here, right? It's a little goofy, no? Take any point, compute its reflection. I mean, it's probably a matrix thing, no? If we reflected it about y equals x, right? Don't you just switch x and y? Take any a, b. Sure, okay. So, you're saying if I have this, like, a comma b, and then I want to figure out, like, where it is here. Please don't forget about me. Oh, there you are, Maria. Yes.
My man.
Yes, I see it, Maria. Okay. What's the equation for that? That to me doesn't seem like anything that's like super intuitive. Yeah, he says, I don't know. Okay. Is this an intentionally hard one? Yeah. Yeah. Right, yeah, if you know slope and a point, but then I gotta find it like perpendicular to this. Well, okay, well the perpendicular slope is -1 then, right? Yeah, okay, cool. Okay. Uh-huh. So what, it's like y equals -x plus b? Let me think. Because, again, if I'm reflecting over y equals x, I just flip x and y, right? Isn't that all I do? Right? Like, for instance, if I had, I don't know, if this was like 2, 1, right? The reflection of that is going to be 1, 2. Yeah, change of variables. That's what I'm thinking. What if I... Okay, yeah, what if we just change our coordinate axis? So instead of doing things... Instead of the parabola... okay, Google, stop. Sometimes it just wants to talk to me. Yeah. Let's move it down. Right? Or move it up. Move it up, right? Yeah, shift the axis up by 2, right? Or wait. No. We want this, our axis of flipping, our axis of symmetry, to come down too. So that means we need to pull the here's what we're doing. Here, sorry, let me sorry, I got too many things. Let me just redraw. Oh well, okay. Let me get rid of this. These were valiant attempts. Yes, exactly. Yeah. I'm gonna show you what I want to do. Right. So, yeah. Exactly. Instead of defining my coordinate axis to be here, I'm going to pull the whole thing down by 2. Which means I'm going to say that this is now my new coordinate system. So now, y equals x squared is now y equals x squared minus 2. Right? And now this is y is equal to x. And then we'll flip it back at the end, right? So now when I swap the coordinates, I get x is equal to y squared minus 2. Okay. But then we need to go back up by 2 units to like get it into the original into the original coordinates it was. So then the y needs to go up by 2. So well, here, let me put some colors on this so we can kind of see what's happening. So this is minus 2, right? And then we need to shift it up by 2. So then we say y goes to y plus 2. Square y equals square root of x plus 2. Yeah, but we don't want the square roots with it, right? Oh wait, no. Y is equal to y minus 2. Okay. So now we I got it. Well, the answer choices don't have anything in it, right? Okay. So then we have y minus 2 squared minus 2. So this is x plus 2 is equal to y minus 2 squared. Oh, which we need to expand out. Okay, fine. So x plus 2 is equal to y squared minus 4y plus 4. So what's that? X is equal to y squared minus 4y plus 2. Cool. I think it's answer choice C. Is it answer choice C? I think so. Cool. Yeah, they give it as x equals. Yeah, so that's what it is. Yeah. Nice. Okay, cool. Good question there, Boomer. I thought it was fun. Okay. Where is Sibley's question? And then Maria, I will do yours. And then Nick, I will do yours. Don't worry, I got time. I explained it better than the official solution? Nice stuff. 1 second, I'm trying to find where I put Sib's question. Here, I'll put this for now. Maria, this is yours. We're going to do yours after I do Sibley's. You got a new PC. Nice one, Kay. What specs you got, bro? What are the specs? What specs you got? Let me go find Sibley's question. This was it. Oh my god, we're doing parameterizations? This is fun. What's up? Stop this. Ugh, come on. Why can't I paste? What the fuck? Wait. Oh, is my keyboard just like not working? Oh dear. Okay. I don't know why it's doing that. Okay. Maria, this is yours. I'm going to do this after I do Sibley's. Let me do Sibs real quick. I hope it's real quick. We'll see. And then I will do Nick's last. Yes. Oh, I see. That's what they said the solution was? Yeah, dude, that's gross, dude. Yeah, you need the visualization for it, honestly. No, you're good, Sib. No, you've been waiting. I appreciate it. We're gonna do yours. Hers makes no sense, Maria. Yeah, I know that does happen. Okay, let's see. Okay. Calculate the surface integral where t is the triangle with vertices 1, 0, 0, 0, 1, 0, 0, 0, 1 of x plus y plus z ds. Oh. That looks terrifying. This is more than calculus. This is vector calculus. This is like beyond calculus. This is college level calculus. Okay. I gotta remember how this works. It's a volume integral, right? Isn't it? Isn't this where we take a surface integral and we turn it into a volume integral? But it's like, oh man, I'm trying to remember how this works. The vertices of the triangle lie on the plane x plus y plus z is equal to 1. Oh, that is true. Right? 1, 0, 0, 0, 1, 0, 0, 0, 1. Oh. Let me try to like draw this a little bit so I can make a little bit of sense. What's going on? Oh, I see. Yes, it's here, here, and here. Uh-huh. Right, okay. And T is the surface. So they want this surface. Okay, so you have to get the normal of this, right? I believe you need like, yeah, these things, these two vectors. You need like two vectors that like describe it. It is it's a surface integral of a scalar. What was this rule again? Man, what is this? Sorry. Yeah, no, there... Man, whose theorem is this thing again? Is this Stokes again? Greens? Maybe it's Greens. Greeny theorem. Mm-hmm. No. Browns, oranges? Fuchsias. I do like fuchsia. I remember when we're doing our this is called like the this part of it. You see how this is like the magnitude of gx cross gy. That's called the, oh man, is it the Jacobian? It's okay, Maria. Don't worry. I'll help you right after this. Just give me a second. I'm just trying to remember how this went. Do the lengths have the same? I think so. Yeah, I think all the sides are the same. I mean, the key thing is like this: x plus y plus z. is equal to 1. I forget. I think you just have to like kind of... Ugh. I remember it's like we come up with, because gx cross gy is what gives you like the normal vector to this, right? I'm trying to remember this. That. Okay. Okay. Yeah. G of x, that's dg dx, right? -1. Okay. This is kind of like Green's theorem. It's kind of like it. Because ddgx cross dg dy. Yeah, okay. What's up, Matthew? Do I remember you? I have a lot of people that come through my servers. Maybe, if you remind me. I see. You do that, and then you do this, you do this, and you do this, and you do this. I feel like that kind of gets you a very similar thing to Green's theorem. This dm dx minus dl dy. We did your algebra. Oh, nice. Okay. Okay. I got you 100. Nice. I'm glad I did. Oh, okay. Wait a minute. I think what's happening here, Sib, is we're defining like a new coordinate system where we're not even worrying about z anymore, right? And then if I'm going from like 0 to 1 here in terms of x, then this line right here is y is equal to 1 minus x. So that's why this goes from 0 to 1 minus x. Okay. It is like a little sick bubble. Okay. I think I kind of get what's happening here. So whenever you have an integral of something that's in like 3-dimensional space, we want to try to reparameterize it into 2-dimensional space. And the way we do that is we recognize that, okay, I could define my 2-dimensional space G here just in terms of x and y, okay? Because my z is always going to be 1 minus x minus y because of this condition. So anytime you have like 1, 1, 1 like this, that is a plane where x plus y plus z is equal to 1. So z, in this case, is equal to 1 minus x minus y, okay? Now, I can map any point on this triangle in terms of just 2 variables, x and y, because you see how z depends on x and y? And so I'm going to say, okay, G is now whatever the x coordinate is, whatever the y coordinate is, the z coordinate is now this, And then here are my restrictions, right? I can either restrict X or I can restrict Y. X has to go... Yeah, that's the only reason. Yeah, exactly. Well, because these are the 3 points. These are the 3 points that the plane passes through. 3 points define a plane, and this defines this plane. I think this is something you're just supposed to recognize. The other way to do it would be to get the equation of a plane from 3 points, which you gotta like, this has to be a vector, this has to be a vector. You have to cross product them together to get your normal vector, and then that like helps you define the equation of the plane. I think the question assumes that you can quickly analyze that this is this. It's one of these things where math is like, oh, it's fairly obvious. I'm like, no, fuck out of here. It's not fairly obvious. Okay, but once you know that, then X at its maximum, right, can only go from 0 to 1. So you think about what the restriction on Y would be, okay? Well, Y can only go from 0. 0 is the lowest Y can be, obviously, right? But it can only go up to 1 minus X. So now that's your bounds here. This becomes, I think, what's kind of called like a Jacobian. And this is the magnitude of like dg dx crossed with dg dy. And then it's dy dx, and then this is the answer. Because the magnitude of this is just the square root of 3, right? The magnitude of 1, 1, 1 is just the square root of 3. And then you're doing the square root of 3 over a triangle, which has a base of 1 and a height of 1. And the area of a triangle is just 1/2 base times height, so that's 1 times 1 times a half. So this is where you get the square root of 3 times 1/2. And that gets you square root of 3 over 2. So I think this is the key jump you have to do. Being able to do this to this, and then this is just mechanical. From what I remember. Yeah. Does that help a little bit, Sid? Yeah? Sorry, it took me a little bit to like dust the rust off my... Alright, nice to see you, Matthew. Glad you could come by, say hi. Help us, help me help you. If you ever need help with your classes, Matthew, just let me know. Yes, cool, awesome. No, I appreciate that question. I will remember this stuff. This is stuff that I really want to know. I haven't, because I never tutor it. I never tutor up to vector calc. So I appreciate you bringing these questions, because then I have to like kind of remember things. And thanks for like hanging around and stuff. You know, I know we got a lot of people. All right, Maria, you here?
My man.
I'll help you out with yours. And then Nick, I'll probably got time for like one of yours. Sorry, it's just kind of a busy day. All right, here we go. Bus leaves station A. I want to know it too. I agree. Feel free to DM me about like what's going on at the UCLA physics department too, please. Let me know. I want to know the tea. Okay. So here, let's draw a little graph here, Maria. Okay. So station A, and it travels south, okay, at 88 kilometers per hour. And we're going to say for 1.2 hours. Okay. And then it reaches station B. It stops for 40 minutes. So say stops 40 minutes before embarking on its return trip to A. On the return trip, it travels... Yeah, I get the meters per second. We'll convert it. 75 kilometers per hour. I think we're going to convert it at the end, if you want. Because it's just... Everything here is already in, like, kilometers per hour and stuff. Yeah, sorry, Nick. I do have to go somewhere in, like, 30 minutes. But we'll be back. We'll be streaming all week. Your test is in 2 weeks. Well, good thing you've been getting help up all until this time. Okay. How long does it take the bus to return to station A? Okay. So I think the first thing you want to figure out is you want to figure out like how much distance is here, okay? Because I have the speed, Maria, that it takes to return from here to here, but I don't have the distance, so I can't figure out the time yet. This is the key thing here we have to remember, right? Distance is equal to speed times time, okay? So I would like to know what this distance is, and I can get that from the first trip when it was going down, because that was 88 kilometers. That was the speed times 1.2 hours, okay? So let's get the distance. So distance from A to B is going to equal to 88 times 1.2. So if we pull that up on our calculator, that gets me 105.6 kilometers. Okay. Which we can convert into meters later, okay? That's just going to be times 1,000. So that's going to be 105,600 meters. Does that make sense so far, Maria? That we got the distance from A to B? Because the speed times time it took to go from A to B gets me the distance from A to B. Now they want to know how long does it take the bus to return to station A. So I think they want to know this amount of time, okay? Which, again, we use our distance, time, whatever equation. So we know that 105.6 kilometers is equal to the speed, which the speed here is 75 kilometers per hour, times the time. Okay? So if I divide both sides here by 75, then I will get the amount of time it takes. So let's divide this by 75. And so that gets me 1.408 hours. Okay? Because here, I'm dividing by 75 kilometers per hour. Dividing by 75 kilometers per hour. So kilometers cancels and you get hours. So time is equal to 1.408 hours. Or we could just say 1.41 hours. Okay. Is that the answer they have in your key, or does she want it in seconds? If you want it in seconds, you just multiply it by 3,600 seconds in an hour. I mean, it's just kind of annoying. 1.41 hours. Okay, cool. Let's leave it as 1.41 hours. Okay, cool. Does that make sense how I got that? Distance, right? Okay, cool. All right. Next part. What is the average speed of the bus for the entire trip? Okay, cool. So here we go. This is our equation. Average speed is equal to distance over time. Or we're going to say total distance. Okay? Now, total distance that was traveled, right? We traveled 105.6 kilometers to go from A to B. And then we traveled another 105.6 to go from B back to A. So the total distance here is 211.2 kilometers. So it's 105.6 kilometers times 2, right? That's the distance we traveled. The amount of time. Okay. So we had 1.2 hours going down. So I'm going to say 1.2 hours here. I had 40 minutes when I was stopped. So 40 minutes is going to be plus 40 over 60 hours. Or the other way to write this is 2/3 of an hour. So 2/3 of an hour. Plus the time it took to get back, which was 1.41 hours. So this was like the waiting. I converted the 40 minutes into hours is what I did, because, I don't know. I feel like they want the average speed in kilometers per hour. That makes more sense, right? I don't really care about meters per second for the bus. Okay, so we do the 105.6 times 2. And then we're going to divide that by 1.2 plus 2/3 plus 1.41. And that's going to give me 64 point, let's say 46 kilometers per hour. Does that make sense? Was that kind of similar to what they got? And you can see that that number is less than the speed going there and the speed coming back because you waited for 40 minutes. Waiting for 40 minutes effectively meant that... I'm so slow now, it makes sense. No, you're okay. I'm glad this makes sense to you now. It's okay. Sometimes you just need to, like, see it. Like, visualizing it. One half radical 50. You gotta break radical 50 into smaller radicals, RK. Okay. Alright, and then here's the cool thing here. It says, what is the average velocity of the bus? Here's the cool thing about average velocity. Average velocity is equal to total displacement. Over time. Okay? Displacement is the difference in position from your starting and your ending. Okay? What is the difference in position from my starting and my ending? Right? Well, I started here. I went there and I came back. Yes, good. Do you see how, like, for the whole trip, so it says for the entire trip. For the entire trip, your starting position and your final position are the same. So the distance between your start and your finish is 0. Right? Because you end right where you started. So 0 over, I don't care how much time this was, like whatever. This is just going to equal to 0. So your average velocity is 0 kilometers per hour. So you can say, like, start equals finish. So finish minus start equals 0. So 0, yep. Answer there is 0. Oh, RK, then that's going to be 5/2 root 2. You're saying this? Yeah, this is going to be 5/2 root 2. Oh, you're very welcome. Yeah, nice, Maria. Yeah, please, you know, we stream 3 times a week. One sec, let me get you the calendar. That's the calendar that'll tell you, like, when we're streaming. So feel free to hop on at any time, and I'm happy to help explain things to you. Also, you get a point. We call them bond coins. You get a point for asking a question on our server. The more questions you ask, the more points you earn, and then we buy you gift cards and stuff. It's all fun. You're very welcome.
My man.
Okay, Nick. Here, I'll do one of yours, and then I really gotta go. So... It's loud? Oh, is it loud? Okay. Yeah. Let me fix that. Thank you for telling me. Yeah, I have no clue what the volume levels are sometimes. I mean, I have a meter, but... oh, fuck. Where is it? Not here. Where is my stuff? Oh, there it is. There you go. Just raise your volume. Brutal. What's up, Czar, man? What's up, my dog? Do you remember me? You're like the 4th person today to say remember me. I unfortunately can't remember all the people that come by my streams. But if you remind me like what question I helped you out with, I might remember it.
Hello.
All right, Nick, what's up? All right, here, let's do this one. All right, assume that a court officer is allowed 25 cents a mile for the use of her automobile for the purpose of conducting defendants to and from court sessions. The first month, she drove 416. Okay, I'm going to highlight some stuff. 416, 328, that, and that. Okay. And then the 5th month, oh, dude, there's so many numbers. Okay, fine. I'm going to stop writing this, actually. Okay. Her expenditures for gasoline is $2.70 per gallon, and her general average miles per gallon was 16. Okay, so we're going to say MPG is equal to 16. I would love for gas to be $2.70 a gallon. It's fucking $6 here.
That's dope.
It's not $2.70. She used 32 quarts of oil. Okay, so 32 quarts. And then I'm going to say at $1.25. And then she also spent $3.51 on upkeep. Without considering depreciation, she would have received above her expenditures. Okay. So okay. So we want to know how much she's going to get, right? She's going to get 25 cents for every mile that she uses her automobile. So we should add up how many miles she uses her automobile for, right?
Mm-hmm.
Okay. So let's just get that real quick. 416 plus 328 plus 2012 plus 187 plus 713 plus 1608. Okay. So she traveled a total of 5,264 miles. Which times 25 cents for each mile. This is how much money she gets back. So she gets $13.16 reimbursed, okay?
Mm-hmm.
So now let's get our costs. Okay. So 351.2, right? That was just general, like, keeping the car working. 32 quarts of oil at $1.25 each. So that's 32 times $1.25. So, okay, minus $40 for oil. That's cheap. And then here we go. This is kind of the tricky thing. So she traveled this many miles. So if you want to figure out how many gallons of gas she used, you divide this by 16. So 5,264 miles. And then we divide this. So what you're doing is you're saying like times 1 gallon is 16 miles. This is like stoichiometry here. So if I do this divided by 16 times 270, that gets me 888. So then we're going to say like times, was it 270 for like 1 gallon. This is going to be minus 888.3 dollars she spent on gas. Okay, so now let's like subtract all this shit. So this minus 351.2 minus 40 minus this 888.3, $36.50 is what she comes out on top. Wow, not very much, but she made a little bit of money, I guess. Good job, government. Okay. That's actually a real thing, though. This is a real thing. You do get reimbursed like per mile and stuff. Yeah. Okay, does that make sense, Nick? We'll have more time tomorrow. Yeah, tomorrow I don't, well, yeah, tomorrow I don't have a student till 8, so today I could only stream for, was this, we're at 2.5 hours? Yeah. Tomorrow I can do 3, maybe 4. Maybe we'll hit a record. But thank you for sticking around, Nick. I appreciate it. Cool. Okay, cool. Sarman says, it was one to do with a bunch of cubes making a cube and how to find how many cubes are exposed. Oh, yeah. Those questions do come up. Okay, cool. All right, let's close out the stream. All right. Thank you, everyone, for coming to Office Hours Actual Education today. I really appreciate all the questions. Had a lot of fun working with you guys. We're back. So, yes, if you have a question, unfortunately, I have to run. But we will be streaming tomorrow. So tomorrow, stream is going to be at 4 p.m. Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. Yes. Funny, Cosmolano. One sec. Let me send this to Nick real quick. So yeah, come on by the stream tomorrow. If you need help, we'll help you guys get a good start to your school year and whatnot. The calendar we use for it is here, calendar.actual.education. I'll post the link here in Twitch. I'll post it in YouTube. And then you can see it also in TikTok. So our stream here is tomorrow, and then we'll have another stream on Wednesday, and then we also have some other fun people. Like Penn Center does awesome streams to help people, and so does Zach. He'll have one on Saturday. He had one today, it looked like. Yeah. Okay, cool.
Yes.
Okay. That being said, let's go raid somebody. We love to go raid people on Twitch. Who are we gonna go? Who are we gonna go say hi to? I will also be on another streamer's channel being interviewed on Friday. I'll let you guys know about that in the Discord. Feel free to join the Discord if you want to be part of the community and stuff. Yes, Dawn. Love Dawn. Okay. Go say hi to Dawn. Dawn's a great friend. Thank you again, everyone, for coming back and joining us for the first Office Hour stream of the fall semester and a new school year. I hope you guys have a wonderful start to your week.
That's dope.
We'll see you tomorrow. Peace.
What is the side